Alright guys, welcome to chapter 3 where we're talking all things parallel and perpendicular. Alright, so before we start to analyze parallel lines, 3.1, real quick section, that's why we have two combined here today. 3.1 introduces the concept of skew, and basically, let's talk about the definitions here. Two lines that do not intersect are either parallel or skew. So the main difference is parallel lines are on the same plane, whereas skew lines are non-coplanar. Also, two planes that do not intersect are called parallel planes. So planes can't be skew, they're either going to intersect or be parallel, but lines can indeed be skew. And basically, if you think about a box, if we analyze the lines, for instance, this line that would be going up and down on the front of the box, and the line going through the back bottom of the box, they are never going to intersect, but they're not parallel. So therefore we needed a new word for that situation, and that gives you skew. There's also some examples here. Lines M and K are skew because they're not going to touch, but they're not parallel. All right, the other thing that 3.1 introduces you to is the identifying pairs of angles. So one of the most important geometric diagrams is what you see right here. When you have two lines and then you have one line that's intersecting both of them. And that intersecting line is called a transversal, a line that intersects two or more coplanar lines at different points. So transversals are typically denoted with a T, like you see here, 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 and here. All right, so now we have four angle pairs when this situation happens. So you think about it, you got two lines, and you have a line intersecting both. You've got 1, 2, 3, 4, 5, 6, 7, 8 angles that are created when this scenario happens. And the different positions were given names. The first one we'll talk about, corresponding. So if you correspond, it's kind of like you go along with someone or something like that. And that's how we think about this in the angle world. So angle 2 is in the top right-hand corner. Angle 6 is in the top right-hand corner of the pairs of angles that are created. So if we would have this angle with this angle, and we would have this angle with this angle, and this angle with this angle. So they just gave you two for a pair of them, for example, 2 and 6, but you would actually have four different pairs of corresponding angles when this scenario happens. Now, alternate interior, the second one. Alternate interior is, it does just that. Alternates means you go back and forth, and interior means you're inside the two lines. So here's the two lines. So the interior are going to be the points in between them. So if you alternate on the interior, you stay on the inside and you go back and forth over the transversal. Similarly, alternate exterior, they go back and forth, but now they're on the outside. So they stay on the exterior of the two lines, and they are alternating back and forth over the transversal. And finally, we have consecutive, which means in a row or next to. Interior. So interior lets you know you're going to stay inside. Now consecutive means you're going to be next to each other and you're not going to alternate. You're going to stay on the same side of the transversal and be on the interior. So four angle pairs that we discuss in this chapter greatly. All right, now we're going to, in class, talk about a GeoGebra lesson where you can set this scenario up. I'm not going to talk too much about it on the video here, but you'll set up a scenario like this and you will find the angles. We'll talk in class about that geogebraically. And we know the main thing we want to notice here is that we have the same angle whenever this occurs when the lines are parallel. So very important concept. When you got parallel lines, you have some magic happening. And here it is in theorem form. All right. The relationships that 3:1 talks about in 3:2, it says, hey, when the lines are parallel, you got all kind of good stuff happening. So parallel lines cut by a transversal, one of the most common scenarios in the world of geometry. And this is what you got. You have the corresponding angles. They are going to be congruent. So 1 will be the same as 5. 2 will be the same as 6. And then you guys know vertically, 2 and 3 will be the same. So 3 will be the same as 7. And 4 will be the same as 8. So corresponding angles will match up and be congruent. And that's what this was trying to illustrate using GeoGebra. The same angles in the corresponding spots when the lines are parallel. This only happens when the lines are parallel. So that's why your hypothesis for all these is if two lines, if two parallel lines, if two parallel lines, if two parallel lines, if two parallel lines. Got to be parallel for these things to happen. The second theorem here, alternate interior angles. So we've got alternate interior, 3 and 6 will be the same, and then 4 and 5 will be the same, congruent. Alternate exterior, so that's 1 and 8 matching up with 2 and, or matching up with each other, and 2 and 7 matching up with each other. Again, alternate exterior are congruent. The only one not congruent of these pairs is a consecutive interior. So consecutive interior angles are going to be supplementary. So that's 3 and 5 and 4 and 6. Again, these all occur only if the two lines are parallel. All right? So you've got congruent, 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 and then supplementary. All right, and what you notice is what's cool is there's really only two different numbers. So say you had like 120, then this would be a 60, and then you could just roll, you know, where the 60s are all be the acute ones, and 120 would be all the obtuse ones. So all these 8 angles, you only have two different numbers. You have the acute ones are all the same, and the obtuse ones are all the same. So if you get stuck on something like this, what I always tell kids, like if you're taking the SAT and you forget all these names and rules and things, just look at the picture. The big ones are all going to be equal to each other. The small ones will all be equal to each other, and then one of each gives you 1/8. That's it in a nutshell. All right, so now let's apply it. Example 1. The measures of 3 of the numbered angles are 120 degrees. Identify all the angles. So right away, I see a 120. I know there's a 120 vertical. I know there's a 120 corresponding. And I know there's a 120 alternate exterior. So that's the explanation. You have vertical for 4. You've got corresponding for 5. And you've got alternate exterior for 8. Now in example 2, they bring in some variables, and so you have to set an equation up and solve it. So I'm finding the value of x here. You're like, okay, well, let's see. I look at this. I have, let's see, a 115, so there will be a 115 there also. And then you know that consecutive interior have to add up to 180, so they're going to be supplementary. All right? So we know, or we can just think logically, right? We have 115 is obtuse, x plus 5 is acute, so an obtuse one and an acute one in the same diagram are going to be supplementary. Alright, so technically what you did though was this explanation here. So one of each adds up to 180, substitute in what you know, and then solve it for the variable. And that's all they wanted here was the value of x. They didn't want you to plug it back in. It would be 65 degrees if you plugged it back in. Alright, example 3. More fun stuff again. Find the value of x. You've got 136 degrees, so you could bring that corresponding right here, 136 degrees. And then, you know, now they make a linear pair. So we can say 136 plus 7x plus 9 has to equal 180. So put your like terms together. 145 plus 7x equals 180. So 7x is 35. So x is 5. If you wanted to plug it back in, you could check and make sure you got 44 for this angle here. 35 plus 9 is 44. There you go. All right, pause the video here. Take a look at the monitored progress, and we'll get back together when you're done. Okay, given measure of angle 3 is 68, and measure of angle 8 is 2x plus 4, so you can fill it in. Well, 68 would go right there with 7. It's an acute one. It's corresponding. So side-by-side angles, linear pair postulate. So I know I can set 68 plus 2x plus 4 equals 180. So 72 plus 2x equals 180. So 2x is 108. So x is 54. What is the value of x? And there you go. And if you plugged it in, you would get 112. 112 and 68 do indeed add up to 180. All right, now the toughest part about this section will be proving things. And so you're going to have to prove from scratch in this section. Prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. All right. So first thing we want to talk about, where is your hypothesis? So there's your hypothesis, and that's going to be your given. And then your conclusion will be what you're trying to prove. All right. So I'll just try to sketch it. I'll try to be neat. Given, oops, given, we're just going to make up two things here. We'll say P parallel to Q. We will prove, all right, let's get a picture here. So two parallel lines cut by a transversal, label it. So let's see, if two parallel lines are parallel, so I know I can put those markings in, the arrows to denote parallel. Now I have to label, so I'll say angle 1 is congruent to angle 2. Alright, so that's the tough part because there's no picture for some of these, so you have to draw and label a diagram and then relate your given and prove to what you call it. So we could all have different ones. If you call it A and B or C and D, then you just have to match up your diagram with your words, given and prove. Alright, now the thing about the world of geometry and proving theorems is, well, you can be like, well, we just learned that 1's the same as 2, they're alternate interior, but you're trying to prove that. So you can't use a theorem to prove itself. You can use anything else in the world of geometry, but you can't use that theorem to prove itself. So you just learned a bunch of other theorems though, and that is going to help guide you. So if you brainstorm it, you could think, all right, well, what do I know for sure about this picture? There's a lot of other things that you know. Like for instance, I know that 1 is the same as this angle. So if I call this angle 3, because they're vertical, and then I know that 3 is the same as 2 because they're corresponding. So therefore, if 1 is 3 and 3 is 2, then 1 is 2 by a property that you remember from last chapter, the transitive property. So you can brainstorm it and think through it before you actually start to write the proof out. And then once you get your idea, you say, all right, I need my statements. I'm going to abbreviate it, and my reasons. And we say the first step is always what is given. And then the next step, what did you talk about? Well, we brainstormed that 1 would be the same as 3. So you label a different angle. You can label every angle if you want. You can go 1 through 8. But you really only need to label the ones you're going to use. So I'm going to say, all right, well, I know that 1 is congruent to 3 because they're vertical. Learned that last chapter. And I know that angle 3 is congruent to angle 2 because they are corresponding. Just learned that in this section. And so therefore, if 1 is 3 and 3 is 2, then angle 1 has to be the same as angle 2 because of our good old transitive property friend. And of course, you don't want to stop until what you were trying to prove is listed. So that's a quick, easy proof of why alternate interior angles are congruent, thanks to a couple old friends, right? Vertical and corresponding. Now, check this out. You can also prove this theorem. Let's say I'm going to show you an alternative approach. Let's use LPP. I know you guys are down with LPP. Yeah, you know me. So how could that help you? Well, check this out. What else do you know? Like, say I put the 3 here. So what else do you know? Well, you know 1 and 3 have to be the same. And you just learned that, 1 and 3 have to be supplementary. And you just learned that 3 and 2 are supplementary. So therefore, 1 should be the same as 2. So let me show you how this one flows. So in this one, we would say angle 1 plus angle 3 equals 180, LPP. And then we know that angle 2 plus angle 3 equals 180 because they are consecutive interior. You just learned that this section. So now it takes a little bit more work because you notice that if 1 and 3 are 180 and 2 and 3 are 180, well, if that equals 180 and that equals 180, then you can set them equal to each other by the transitive property. So angle 1 plus angle 3 equals angle 2 plus angle 3. And there's your transitive partner in crime. And then we're trying to get 1 matched up with 2. Well, we can just subtract. So this one would involve 1 extra step. That's why it's not the most common way to do it, but I wanted to show you that it is indeed legit. So now we could say angle 1 is congruent to angle 2 by subtraction. And some geometry books will make you keep it as an equation and then flip it back, using the definition of congruence, but I'm easy like Sunday morning, baby. That's all you need to do for me. All right, so that's a wrap on 3132. Peace.